In the blockchain space, governance is never an easy topic to discuss, but Polkadot is trying to formalize the set of rules that will happen on-chain. In this workshop, Amar Singh and Dr. Alistair Stewart are going to teach you about how are they envisioning the Polkadot's governance system. Of course, you can always follow more on polkadot.network/a walkthrough of Polkadot's governance. This is on their blog. It's very easy to find. I hope you guys enjoy. Stay tuned and don't forget to subscribe to the channel.
Alright, so this is a quote from Vitalik, and I read this quote like a year ago at DotCon 5, and I feel like it really resonated with me, or my understanding of like the innovation that blockchain provides. So the quote reads, "The Nakamoto blockchain is a system that defines an asset inside of itself, and that asset is responsible for incentivizing the system's continued existence." And basically what this is saying is that the issuance of the cryptocurrency is what ensures the security of the system. So if we look at Bitcoin, Bitcoin's issuance schedule is immutable, and that's part of the value proposition that it provides. Is that by providing a predictable way of determining what's going to happen, people can view it as digital gold, as an immutable store of value that you can trust isn't going to have any significant changes. So static conservative governance is part of Bitcoin's value proposition. And this is very different from modern smart contract platforms, which need to adapt and evolve according to a changing set of stakeholders. So blockchain platforms, especially modern blockchain platforms like Polkadot, need to be perceived as a public commons, positioned for application developers and parachain developers as well. And it's going to have a diverse and changing stakeholder set. We're not even going to be done when we secure the protocol layer. The vision really has to ensure interaction with stakeholders on every layer of the stack. So we have to really consider how we can change the system to adapt to new stakeholders. And then I said this in a previous talk, but progress is not monotonic, and upgradability is always necessary. Even when we find new solutions, oftentimes solutions come with new problems. So governance, and if you're wondering like what is governance, governance is how we coordinate runtime upgrades. It's how we come to agreement on how we make changes to the system, or how we change the system. So this is sort of the technical side of runtime upgrades, which is that the Rust runtime code is compiled down to WebAssembly, and that WebAssembly blob is placed on chain. And if you're wondering like, can any, is any arbitrary code update and upgrade, and the idea behind governance is really that we set standards on what changes to the code can be done in order to, or when we upgrade. So governance is like not necessarily this picture, it's how we decide when to initiate this sort of process. And we said this before, but governance is how the stakeholders agree on upgrades. And then the second point has to do with something called meta-governance, but it's the idea that we actually have to come to agreement on how we make changes, how we even agree to change the system. And that's something that previous blockchains haven't really been able to touch. So now Al's going to talk about the stakeholders.
Right, so who are the stakeholders in Polkadot? So naively, we know the actors involved in actually running and securing the chain, collators, validators, their nominators. But more broadly, we can sort of consider this and the developers who make both the relay chain and the parachain logic. But the people we actually consider as the primary people that are involved in governance, the system of the coin holders, which includes the validators, their nominators, various investors, and actually the parachains themselves are going to have dots because they need to raise dots to become a parachain. But there are other stakeholders that aren't included in the dot holders, basically the end users and other people in the system. So how do we design a system to work with these stakeholders? Well, basically, so the simple thing to do is coin voting, maybe. And that's kind of a plutocracy. And broadly speaking is what we're going with. Which means so coin voting kind of neglects stakeholders that don't have dots. Naively doing coin voting has the problem that often the voter turnout is low. So I think this is, if you look at, say, the voter turnout for, say, Aragon, you'll find it's quite low. And only by having slightly different systems can you get a higher turnout. Now, we can't really solve, so one reason to go with coin voting is that we avoid symbol attacks that would otherwise be easy if we have other definitions of who the various other stakeholders are. But even if we end up being a plutocracy, we still want this to be, fair, to hopefully not be too centralized. So I mean, like, how else could you do it to avoid being a plutocracy? Well,
yeah, so Vlad said the quote up there, Vlad Zamfir said the quote at the top, and he's defining what he calls rough consensus, which is the idea that just because we're making collective decisions doesn't mean that we need to agree on the criteria for making these decisions. So it's like keep everything as undefined as possible, and that allows us to avoid capture sort of trivially. And the idea behind this, like in terms of actual organization, this is done through community calls and forums, and the idea is to incorporate as many new stakeholders as possible. But what happens in practice is that decisions often converge to a few personalities, and the final decisions are often interpreted by a very small minority. So our goal is really to make the whole process more transparent, easily auditable, and sort of demonstrate when stakeholder interactions are happening on-chain.
Right, so lots of government systems in practice are either captured by a small minority or end up being a plutocracy. So we're kind of designing a coin-voted system from the start. Hopefully it can be fair, and ideally, depending on how things work, it's going to be fairly centralized.
Yeah, I can talk about this. So there's, like, I guess when we're thinking about our system before we introduce the system, like what is the criteria? What are we trying to build or design? And the first criteria is that changes should happen at a consensus-driven pace. And this is sort of difficult to define, but it's like consensus-driven as in the pace at which the participants agree is appropriate to proceed. And once again, this is like that meta-governance thing that I talked about before, which is like governance of the governance system. So that's the first sort of criteria. And the second part is to make it so that our system can adapt and change according to a dynamic stakeholder set. So if new stakeholders join the system, how can we use the council, which we're about to talk about, to incorporate that stakeholder's interests?
Yeah, so what essentially is part of our solution to the low turnout problem is we're going to have other bodies. We're going to have an elected council. The council will be elected by DOS holders. It's going to have a relatively small number of people, maybe 12, maybe 24. And the job of the council members is, so essentially we want to have a system where the coin holders are sovereign, and so they'll be the people making proposals, but the council gets to sort of bias these with these proposals, decide whether it likes these proposals or not, and that will help whether or not these proposals pass. It helps with the timing, so the council has the power to fast-track proposals for emergencies. It also has the power to veto proposals if we discover a security hole in something after it's been submitted. And so the way the system sort of works is, so first we have the proposal that will be submitted as a transaction by someone. Maybe it's a runtime upgrade, it will have the code in there. Maybe it does some of the other things that can only be done by pseudo people, like moving the treasury money around or something. And then this is sort of going to be voted on by stakers. People are going to be able to put stake behind this. And there's something where every now and again proposals come up. And the council can kind of interrupt this with its fast track thing. But so what happens after proposals is the council gets to vote. And this can decide, can change when the referendum happens and the bias, which I'll get to later. And then it will go to a public referendum stage. And now every dot holder can send a transaction to the relay chain that's a vote, and we look to see if this won or lost, and then we update the runtime. And all this happens, automatically on chain. So the purpose of the council is to basically to review these runtime upgrades which are submitted and sort of decide the general direction. And in particular, we want to mitigate the problem that happens with things that turn out to be dangerous, or on the other side to make sure that we can have fasting, get results through fasting in an emergency. And so basically they have to, their purpose is to filter the set of runtime upgrade proposals and to bias these things and to sort of represent the general well-being of the system.
Okay, so this was the first bullet of the presentation, and we moved away from it for a while, but the point of this slide is that Bitcoin and a lot of these other previous experiments gave us systems that issued cryptocurrency, a native asset, in order to incentivize the continued security of the system. And that is an innovation in itself. But what we're doing is we're adding something else. We're adding the ability to coordinate changes using the native asset as well. And that's through stake-weighted voting systems. So now we're going to go through a few scenarios, or really just one scenario, and then a few mock proposals. So in this scenario, we have a few stakeholder personas that we've identified. A dot whale, Alice, a parachain engineer, Bob, a community organizer, Carly, and validator, Delphi. And each of these stakeholders have different incentives. Sometimes their incentives align, but other times they don't. So first we're going to go over the election, how the council election happens.
Okay, so I better say that Gab this morning indicated that we might well not be going with this procedure I'm about to describe, but that was too late to change the slides. But I'll try and explain that a bit later. So the existing thing that was implemented is we have rolling elections. And the votes are by approval voting, but we make this not entirely just going to, make it so minorities are slightly better represented by accumulating votes that don't get used. And so say we have an election and we count up the votes. Now this is approval voting, so one person can vote for count for multiple of these things. And suppose in the first one, Alice wins with 60 and gets in, and we have a few other votes, including these 25 votes for Carly. And for some reason it's Carly who these slides are biased towards, the community organizer. And she loses this first election. And then we have a second election. And now we don't get any votes for Alice because she's already in. But people are voting for Bob and Carly and still ENF. And Bob got 70 votes. He didn't get any votes last time. No, but okay. And he wins the election. But Carly's vote is accumulating. Presumably none of these 25 people voted for Alice in the first election. And then finally, this third time she gets enough votes to get in. I didn't explain that very well, but it doesn't matter because it's changing. So we have rolling council elections. The purpose of the council, again, is to represent stakeholder interest, basically by biasing, filtering proposals. So let's have some mock proposals. So the way transaction fees currently work is we try and adjust transaction fees slowly so that we end up with a 25% full block. 25% of the maximum capacity. And we could maybe think of changing that to 50%. So it doesn't make sense to adjust transaction fees individually because we have an automated adjustment mechanism, but maybe 25% is too low, and if we're not worried about transaction fees going to zero because no one uses the network, we can up it a bit. And so suppose we make this proposal, and now sort of the coin holders are sovereign. If they turn out 100% and the majority support this proposal, then it happens, whatever the council did. So suppose this thing happens. I mean, do you want to explain any of these?
I was going to do the next two.
Oh, well, hang on, but I should explain. I should explain what we're considering replacing the council selection mechanism with. So one of the problems with the council design is we're not quite sure yet how to make a rolling election fair. But we have this method already implemented, fragments method that we're using for selecting validators. And that sort of has this very nice proportional representation property. Like if 40% of people want a particular thing and they organize properly to get enough council members, then they're sort of guaranteed to have 40% of the council. So this will sort of guarantee that minorities are reasonably represented if they can coordinate. The downside is we only know how to elect all council at once this way. But it seems reasonable that we might switch to this. So
yeah, so if this was the proposal, like we're going through a mock scenario, then if coin holder turnout is low, but the council signals significant support, then we have what is called negative turnout bias. I know the name is confusing because it sounds like it should be positive turnout bias, but it basically makes it so that it lowers the threshold required for proposal passage. And this is in the context of a council that is in unanimous support for the given proposal. So in this case, I think we probably see a technical committee as the council that signaled significant support, and then the coin holder vote wouldn't have to require significant turnout. Okay.
So concretely, what these numbers actually mean, so if the council is against something, we don't want it to happen on a low turnout. So what we actually do is we scale down the yes votes by the square root of the turnout. The turnout is a number between 0 and 1, and then compare that with the no votes, and so this means that we need a bigger threshold to pass something. And for some terrible reason, this is called positive turnout bias, because we biased the positive thing. And on the other hand, if we have unanimous council support, we want to, by default, think this is probably a good idea, and then we lower the threshold by scaling the no votes. In sort of a frequently case where we're going to have majority council support, we think this is a good idea, but we don't have unanimous, it's not uncontroversial, then we'll pull back to a majority of public coin holders, whatever the turnout.
Okay, so now I'm going to present a scenario that I think actually might occur sometime in the far future, and it sort of identifies clear stakeholder conflicts between the liquid dot holders and the dot holders that are recipients of the block rewards. So for context, dot issuance, in terms of the block rewards for validators, dot issuance is often matched with capital that is locked up to the treasury. And this is all in an on-dilution function in the treasury module. But the idea behind this is to keep the proportion of tokens staked constant even after we're issuing tokens. So that makes it so that the cost of attacking the chain is the same as it was before, because the proportion of tokens staked is the same. And parachains, so like parachains are sort of one of those stakeholders that don't get access to the stream of rewards. So they're DOT holders who aren't getting part of the block reward scheme. And if they don't participate in inflation rewards, then some of their purchasing power is actually redistributed from them to validators. And this isn't explicit, this is how economics works. So whenever inflation occurs in the economy, you're seeing a redistribution of funds from the people who receive the money last to the people who receive it first. And the reason for that is that supply adjusts when you increase supply, so price goes down, so you adjust supply and the price goes down, but that happens over time. It doesn't happen all at once. So if I had 100 coins here and they were worth $100, and then I printed another 100 coins, the same exact thing, and now each coin is worth 50 cents, like that transition from $1 to 50 cents doesn't happen all at once. It would happen gradually as I like sort of distribute these funds throughout the economy. So if you received the newly minted funds last, then it's really an implicit tax on your ownership of the assets, their assets to be depreciated. So, and then validators would obviously prefer more inflation because that corresponds to the rewards, but it also corresponds to the security of the system. So that's sort of the way that you could see these two sides arguing it. And in a low price environment, security is quite important in a proof of stake system. So this is the proposal that you might see happen, where basically the parachains could propose removing the matching deposit to the treasury during the validator rewards, and you could uphold this invariant of keeping the proportion of tokens staked constant by vesting 50% of the validator rewards in the validator's like stash account is what we call it. So the account where they lock up funds, and we could vest the release of those funds over time. And this would achieve the same functional purpose of keeping the proportion of tokens staked in the system constant while also allowing for the same reward to validators. It's just a bit discounted because it's not liquid. So then this is the proposal justification. The justification is that high inflation extracts purchasing power from all the DOT holders that aren't validators or aren't receiving funds from the block rewards, and that vesting doesn't actually change the validator reward in the long run. So this is a proposal that could make a lot of sense for the system if everything was going well and inflation was an issue as well as high price. So the validators would oppose, as I said before, and their justification would be that they want to keep the proportion of tokens staked constant. And they would obviously also prefer liquid rewards. In other systems, liquid rewards are quite common, but they don't always align incentives in proof of stake.
Well, yeah, so nominators and validators against this, but validators in particular have a reason to have liquid rewards because they have ongoing costs.
Yeah.
Richard.
Okay, but yeah, not all the rewards have to be liquid. They manage ongoing costs, though.
And if it's not worth validating, then we're not secure.
Yeah, okay. Okay, so a second proposal could be instead of adjusting the block reward distribution, you could also, and I think this one actually makes a lot of sense, and maybe Kusama will see this, but you could split the block reward or the transaction fee. So right now the transaction fee on the relay chain is distributed, 20% is distributed to validators or block authors, and the 80% is sent to the treasury. And the point of sending 80% to the treasury is once again to over collateralize the system so that it's robust against outside attacks. But a proposal, and this would probably not be very controversial if the system is up and running and it seems to be very secure, the proposal could be to split 50% between block authors and treasury. And if the system became very secure and it was almost over collateralized, then eventually you don't have to continue diluting so many funds to the treasury. So yeah, in this situation, if we took the same block reward or the same transaction fee and we split it 50% between block authors and 50% between the treasury, we actually also increase validator incentive to include transactions in blocks because we're increasing the amount of funds that they would get if they did so.
which of course means less empty blocks, like sometimes happens on Bitcoin.
Okay. So this is, what time are we at? Let me see. Okay, we're right around 30 minutes. So I'll do this proposal and then I'll open it up for questions. But the point of this proposal is to show how the system can adapt and change over time. And it's a pretty significant proposal. But the basic idea is to simulate or do exactly what conventional monetary policy bodies do and convey expectations of where the issuance schedule is going to go ahead of time. So if you're unfamiliar, in Polkadot, the issuance schedule isn't determined ahead of time. And at the beginning, I showed how in Bitcoin, we know exactly how many tokens are going to be minted as well as when they're going to be minted. So in this sort of system, it makes a lot more sense to coordinate a release of expectations among the stakeholder groups. So the idea of futarchy is like sort of the notion that this is based on, but it's to define reasonable expectations for future proposed changes to issuance. And then you're conveying the expectations of the stakeholders, and this is supposed to be conducive to predictability and stable governance. Okay. So if we look at existing systems, and we should take inspiration from existing systems, even if they sometimes have complexity, the US Federal Reserve uses this thing called forward guidance. And forward guidance basically means that they release reports and they also release like projections on the state of the economy, the economic outlook, and how they're going to respond to multiple events within the economy. And then stakeholders like banks or even consumers, they use the Fed's outlook to inform their spending decisions. So that helps them act because they know what the Fed is going to do next. And in this way, forward guidance often has a tangible influence on economic conditions in the world, even right after the release. So the Fed updates its guidance, and then stakeholders almost make it happen. They almost adjust their expectations to the Fed's guidance, and in some cases that can actually push interest rates right up to where the Fed projected them to be. So the whole idea behind forward guidance is that we're relaying expectations of the stakeholders within the system, and what the Fed uses actually when they coordinate interest rates, it's like funny, is they use the dot plot, like that's what they call it. And it anchors proposals to expectations, and it prevents like any rash, radical monetary policy, because it would just, what would happen if you submitted a change in interest rates that was like a few standard deviations from where it is on the dot plot, the markets would basically panic, and that would be like bad for the Fed in terms of their mandate. And then the Fed meeting minutes discuss the factors that contribute to these dot plot expectations. So this is the dot plot, and we can almost imagine, if we created a metric for issuance, for measuring issuance or inflation simply based on the number of coins minted, we can imagine a plot among stakeholders where they basically say, these are my issuance expectations, this is the range that I'm comfortable with, and then we could use that to decide what issuance proposals make sense and are worth pursuing. And then it could also help filter out any radical issuance proposals. And the way this could work is like, I don't envision it being like a strong bound between like the lowest issuance value projected and the highest issuance value. Rather, I imagine it being something where like maybe the bond on the proposal is actually linked to how many standard deviations the proposal is away from some median. So the idea is you could make any proposal, but it would be very expensive if your proposal veered from the expectation projections. Okay. So the idea, like I said before, is like council members on this council would project reasonable issuance ranges for like some defined period of time, and the projections would be compared to the proposals, and we could even call this the dot plot, and it would make a lot more sense to us than the Fed. So that's like it's just a rough idea, but I think it would be kind of cool, and I think we do need more clarity on the issuance schedule within the system. So excited to maybe try and propose this on Kusama. But the point of that example wasn't to make this proposal to you all. It's really to demonstrate what I perceive as the value proposition of the council, which is to allow us to coordinate a reasonable range for expected changes in the future. going back to this idea of meta-governance where we need to govern the system itself, it's also important to communicate to outside stakeholders the expected range so that they can act based on how they expect the system will be in a few months or years. So this is sort of like the concluding slide, like what we took away from this. Governance is how we coordinate runtime upgrades, and flow is basically like we want to define rules that allow us to make decisions, and these decisions are, or we're held accountable by these decisions by the system. And if the system is done, like these last two things are sort of the way we need to think of governance within a blockchain platform is if it's too slow, it's going to start stagnating and it's going to be neglected and fall behind. And if it's too fast, then we're going to see a lot of volatility. So that's why I think that perceiving the council as a way for governing how fast changes can be made is sort of like a valuable way of thinking about it. Now, here are a few projects and resources. If you want to learn about substrate governance, I would say the best resource is just go to the Treasury and read through the Treasury code. And even if you don't know Rust, the Treasury code is probably, I would say, other than the example module, like the simplest module to understand these mechanics. And it does do like dilution, and it funds certain things as well. So like the requisite methods are in there. I've written the substrate recipes, which will be updated over the next 2 weeks to the Substrate v2.0 API, so that's useful. And then there's a private network tutorial that I particularly like. It's on our Substrate Developer Hub. It's by Gautam and Joshi. And then in terms of projects, I'm like a side project that I'm doing, and I don't know when or if this will be done, but it's a fun coordination DAO on Substrate. Could be cool if it was a DAO as a pair thread. That would be pretty cool. But it's a side project, so sort of focusing on this stuff, but that might be a good example to look at eventually. And then I really like this sample by Ricardo. It's on decentralized identity. I think if he builds out this sample, all of our governance applications, or all governance applications built on Polkadot, are going to black box this notion of identity. So it'd be really useful to have some sort of decentralized identifier. So that's a tutorial, or like up and coming tutorial. I think that's it. Thank you. Okay, so now we can take questions, if anyone has any questions.
Then what happens is you can be in a situation where if you want, so suppose there's negative turnout bias, right? When if there's a low turnout, then it passes. Then it can be in a situation where you're not incentivized to vote yes if you want to vote yes, because you get a bigger influence by lowering the turnout. So the square root gets around that. It now is worth your while voting yes if you want yes to happen. And other than that is just draw a few graphs and see it probably looks sensible. But this number, if you think you can change it to something more sensible, but it definitely shouldn't just be multiplied by the turnout. In a cold wallet somewhere safe, we get out for an emergency vote, you just can't get to the right place, and so it's obviously more important to you to secure your dots than it is to vote on this proposal.
Right, so it's sort of a UX problem around custody.
Well, actually, I don't think it's worth like targeting like a really high voter turnout for every election. If you like consider how we come to most opinions, you know, we delegate signal, or delegate like sort of signal to like experts that we appreciate and respect. We don't often like start from first principles on every new idea. So in this context, I feel like the idea of the council, and like in my opinion, how we scale these sorts of systems is through creating ways to delegate signal on chain in a transparent and auditable way. So instead of voting, like how can I support people that represent my views?
But you need to kind of design a sensible system to that. I mean, I think Tezos, for instance, do delegation for voting the same way they do delegation to bakers, but we don't really want that, and they in fact get a high turnout of bakers by arm twisting only a few people to vote. And we might consider some sort of liquid democracy where you can delegate your vote, but we'd have to like look into what the effect of that would be, maybe later.
Thank you.
like time lock functions.
This is we have a separate biasing mechanism that works by, if you have lock tokens, then your vote is increased. And it's also true that if you are locked for some other tokens are locked for some other reason, say you're a staker, that automatically increases your vote. And part of the reason for that is we want people to be invested in, the people who are invested in the long-term health of the system to be worth more than people who are thinking of the short-term profit. Oh, in particular, and we also have this, if you win a vote, you can be locked for a bit period as well. But the time lock voting, I think, is sort of more principled. If you prepare to lock stake, we know you're interested in the long-term future of the system. And in particular, validators, nominators, and maybe parachains too are going to get benefit from this effect.
Any other questions?
Can I have a quick one? Another quick one. Nominators, can they vote? Just quick questions.
Yeah,
They can.
nominators can
Yeah.
vote.
And also, I see that the model is that the nominator has pretty much an incentive to vote for the validators that are with less tokens staked, so they increase a little bit the amount of stakes that
That's
they have.
okay. That's not part of the governance system, but yes, nominators are going to be incentivized to vote for the validators who are sort of the least popular at the minute. But the sort of system automatically assigns votes, so you don't have to run the risk of I vote for the least popular person, maybe they don't get in at all. Instead, you can vote for a popular person and a less popular person, and then you get back the less popular person.
I see. And how would you prevent like nominator collusion? So they all vote for
Well, if they all vote
together
for
for a specific validator that is doing awkward things in the system. Do you have any mechanism for that?
So again, it's by number of dots. If nominators have a significant portion of the dots in the system, they can attack it. And the way we designed it is to hope that the nominators with will be sensible if they have dots themselves. It costs quite a lot to do that.
I see. Okay, thanks.
More questions?